Today we're going to look at angles and radians and degrees on the unit circle with our trig functions. First of all, let's go through these vocabulary words here. An angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. Now what in the world does that mean? Look right here. You see that we have the x and the y-axis. Here's our x-axis and here's our y-axis. Remember, when the x and the y-axis intersect, they intersect at one point, which is called the origin, okay, with the order pair 0, 0. And it also divides our coordinate plane into 4 quadrants. We've got quadrant 1. Quadrant 1 is a positive quadrant, positive x and positive y. We've got quadrant 2, negative x and positive y. We've got quadrant 3, negative x, negative y. So quadrant 3 is our negative quadrant. And then we've got quadrant 4, which is positive x and negative y. Okay, also it's going to divide into different degrees. Quadrant 1 is going to be formed from 0 degrees to 90 degrees. See how it makes a right angle? That makes quadrant 2 90 degrees to 180. Quadrant 3 is 180 degrees to 270 degrees, and quadrant 4 is 270 to 360 degrees. Okay, you don't see the 360 on here, but if you add another 90 to 270, it's 360. Okay, so the 4 quadrants also divide into all these degrees. So it's telling us here that an angle would be considered in standard form when the vertex is on the origin and one ray lies on the positive x-axis. So the vertex of our angle has to be at the origin, and one of the sides of our angles has to be on the positive x-axis. So we see this angle right here is in standard form because the vertex is at the origin. This side lays on the positive x-axis, and then this side is somewhere out in our coordinate plane. Okay, now let's figure out what all these things are called. The first thing we have is the ray on the x-axis is called the initial side. Okay, so from here to here, this is the ray. Remember, a ray is an endpoint and goes forever in the other direction. Okay, it's on the positive x-axis, so this is the initial side. The other ray is called the terminal side. Now this one is going to be somewhere out in the coordinate plane. It may be on one of these axes, and that's okay. Or it could be floating around in a quadrant. But whatever the case, this is called the terminal side. Now this side is also a ray. It has an endpoint here at the origin, and then it extends forever in the other direction. So the initial side has to be on the positive x-axis. The terminal side can be anywhere floating in our coordinate plane. Initial side, terminal side. The vertex of this angle has got to be at the origin for this angle to be considered standard form. So the ray on the x-axis is the initial side. The other ray is the terminal side. Now when you're measuring angles on the coordinate plane, you can go in 2 directions. You can go counterclockwise and you can go clockwise. Now if you go counterclockwise, remember that's in the opposite direction of the clock. Your angles are always going to be positive. You see how this angle is starting at the initial side and going to the terminal side? That's how you measure an angle, initial to terminal. Since this one is going from the initial and the terminal in this direction, you see the arrow right here? It's telling us our angle is going in this direction. That's against the clock, isn't it? So that's what we would call counterclockwise. Since this is going counterclockwise, this is a positive angle. Now, if we had started at the initial side and gone in this direction and pointed our arrow, that is the direction of the clock. We call that clockwise. And anytime your angle goes clockwise, it's a negative angle. And yes, you can have negative angles. So, counterclockwise rotations result in positive angle measures. Clockwise rotations result in negative angle measures. Now, when you take one complete revolution around the coordinate plane, you have done 360 degrees. just like a circle. Keep that in mind. All right, so let's think about what we just talked about, and let's see if we can sketch some angles in standard position. So look at number one. Number one is 75 degrees. Looking at this little generic coordinate plane we've drawn up here, 75 degrees is going to fall between 0 and 90 degrees. Now, since you don't have a protractor, you are going to do some estimates here. Okay, so we know that a 75-degree angle is going to be between 0 and 90 degrees because I know this is 0 degrees and I know that this is 90 degrees. This is 180 degrees. This is 270 degrees, and of course this would be 360 degrees. Now 75 degrees is going to be in this first quadrant. So I know that half of 90 degrees is 45 degrees. So I'm going to go a little bit more than that, right? So to be in standard form, your vertex point has got to be on the origin. Your initial side has got to be on the positive x-axis, so let's draw that ray right there. And then here's half, so 45. Let's go ahead and make our 75 about right here. Okay, now this is a positive angle because it's positive 75. So from the initial side to the terminal side, we're going to go counterclockwise. Okay, so just make your angle swoop that way and point an arrow. And this will be my 75-degree angle. So that wasn't so bad, was it? So again, vertex point. Then this ray has got to be on the positive x-axis. We call this one the initial side. Okay, the terminal side will complete our angle, okay, and it's going to be floating around somewhere on the coordinate plane. If it's a positive angle, it has to go counterclockwise. That's against the clock. Oh my goodness, look at this one, negative 160 degrees. Well, let's think about what we know here. This is 0. 90, 180, 270, 360, right? This is counterclockwise, but this is a negative angle. So when you have a negative angle, you have to go clockwise. So this will still be 0, right? But if we're going clockwise, this will be negative 90 degrees. This will be negative 180 degrees. This will be negative 270 degrees. And this will be negative 360 degrees. Wow, okay? So I know that negative 160 will be between negative 90 and negative 180. So let's put our vertex point on the origin. The initial side has got to be on the positive x-axis to be in standard form, but as opposed to this angle where we went counterclockwise, this one we're going to have to go clockwise because it is a negative angle. So I know it's going to be here. If this is negative 180, I'm going to draw it pretty close in that direction, okay? And we're going to go clockwise this time. And that is how you draw a negative angle on the coordinate plane. It's pretty cool too, isn't it? All right, now let's look at number 3. This one's a little bit on the crazy side, isn't it? Okay, so with this one, you see that we have 430 degrees. One full revolution is 360 degrees. So if I look and see that this one is 430 degrees, that tells me that I'm going more than one revolution here. So let's do 430 degrees minus 360 degrees, and let's see what's left over. 0 minus 0 is 0. Let's go ahead and borrow and rename. 13 minus 6 is 7. So I end up with 70 degrees. So once again, go to your vertex. It's going to be your origin. Draw your initial side. Now your terminal side is going to be at 70 degrees. Okay, but you have to start here at the terminal side and you have to make one complete revolution. That's your 360 degrees. Then you're going to keep on going and hit that terminal side until you get that extra 70. So when you go past 360 degrees, you have to start at the initial side and make one swoop. That's 360 degrees. And then you've got to go an additional 70 degrees to get your 430 degrees. Now, if you subtract twice and you make 2 revolutions, you'll just do a swoop, and then you'll swoop again, and you'll go to whatever is left. So if you have an angle that's greater than 360 degrees, go ahead and subtract, and whatever is left is where your terminal side is going to be. Okay? So that is how you draw an angle. Positive angles have to go counterclockwise. Negative angles have to go clockwise. And then if they are greater than 360 degrees, subtract your angle from 360 and whatever is left, that's the angle that you're going to draw. But make sure you account for that extra 360 degrees. You have to make one complete revolution and then go to the 70 degrees. Okay? All right, so now let's talk about radians. Everything that you have done thus far has been in degrees, okay? But there's an alternate measurement with our unit circle that we're going to be talking about soon, which is radians. All right, it's taking the same angle but measuring it with radians, which is your pi values. It deals with pi. A radian is a unit of angle measure based on arc length. Well, what's arc length? Okay, look right here at our circle. Okay, the center of the circle extends to the side, and that's what we call our radius, isn't it? Okay, when you have 2 radii, what this does, it creates a segment right here, doesn't it? In between the 2 radii on the circle, that's your arc. So the arc length is the distance or the length from here to here. So, a radian is a unit of angle measure based on arc length. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the arc. Recall that the circumference of a circle is 2 times the radius times pi. So, if you have 360 degrees, remember that's 1 complete or 1 full revolution, that's equal to 2 pi radians. If you have 180 degrees, now remember 180 degrees, that's just half of a revolution. That's equal to pi radians, okay? So, when the radius is equal to the length of the arc, then you are dealing with 1 radian, okay? So, in order to deal with the degrees and radians, you need to be able to convert between the two. Again, all of these are degrees. But if we want to convert to radians, we're going to have to deal with pi. So to convert from degrees to radians, what you'll do is you'll take your degrees and you'll multiply it by pi over 180. To convert from radians to degrees, you'll take your radians and multiply it by 180 over pi. So with that being said, let's convert from degrees to radians. Now, degrees to radians is degrees times pi over 180. Okay, so we have 30 degrees, and we want to convert it to radians. So we'll take our 30 degrees, and we'll multiply it times pi radians over 180. Okay, so that's actually going to give me 30 pi over 180. So the degrees here are actually going to cancel each other out, and you have 30 over 180. 30 over 180 is going to reduce by 30. 30 will go into 30 one time, giving me 1 pi. 30 will go into 180 6 times. So I end up with pi over 6 radians. Let's look at the next one, 150 degrees. To change 150 degrees into radians, multiply pi over 180. And that will give me 150 pi over 180. Now 150 and 180 will reduce by 30. 30 will go into 150 5 times, which will give me 5 pi. 30 will go into 180 6 times. So I get 5 pi over 6, again, radians. I just ran out of room there. You can convert a negative as well. Negative 220 degrees times pi over 180. That's going to give me negative 220 pi over 180. Now 220 and 18 are going to reduce by 20. 22 divided by 20 is going to give me 11, so that's going to be negative 11 pi. 180 divided by 20 is going to give me 9. So I end up with negative 11 pi over 9. So I've converted my degrees into my radians. Degrees to radians. Degrees to radians. Now, same angle. It would look exactly the same on the coordinate plane or the unit circle, but it's just a different measure. Okay? Now let's convert from radians to degrees. Now to convert from radians to degrees, you take your radians and multiply it by 180 over pi. So if I've got 4 pi over 3 and I want to change it to degrees, I have to multiply by 180 over pi. The reason we do this is so that we can cancel out these pi's right here. Okay, so we'll have 180 times 4, which is 720, and then 3 times 1, which is 3. 720 divided by 3 is going to give us 240. Now we're talking about degrees, so make sure you put your degree sign. Next, we have negative 5 pi over 36. Let's multiply this by 180 over pi, and our pi's will cancel out. Okay? Multiply negative 5 times 180, and that's going to give us negative 900 over 36 times 1, which is 36. Now you could have reduced right here to make your multiplication easier, or you could just multiply it straight across, because 36 will go into 925 times. So we'll end up with negative 25 degrees. And again, don't forget that degree symbol. It's very important. Next, we've got 7 pi over 4, and we want to change it to degrees. To do that, we're going to do 180 over pi. Now your pi is going to cancel out. And again, yes, you can cross cancel here, or you can just multiply straight across. 7 times 180 is going to give us 1,260, and then 4 times 1 is 4. Divide it out, and you'll get 315 degrees. So that was a lot of information. Hopefully all of that stuck, and so I want you to practice the sheet that I have for you on your haiku page and see how you do.